So this question says, if the ball lands 2.5 meters away, how much time was it in the air? So this 2.5 meters is on top of the 4 that it already left the table with. But since we're talking about separate intervals, we don't even care about it. So when we look at our chart, we have x and then we have y. So in the previous problem, we figured out the x velocity that it left the table with. So the initial x is 5.33 meters per second. The initial y, because it's a horizontally launched projectile, is 0. That's what happens. Acceleration in the x direction is 0. Acceleration in the y is gravity, which is -10. And then if we keep going with information that we know, we, at this point, don't really know anything from the previous problem. But now we know that the delta x is going to be 2.5 meters. The problem wants us to figure out how much time it was in the air. Now time, for a horizontally launched projectile, is going to be equivalent. So time x equals time y. So time y equals what? So based on what we know more information in the x side than we do in the y side. If we look at the y, we don't know anything that can help us find time. But for the x side, we know that velocity in the x direction is equal to delta x over t. So since we know the velocity was 5.33, we know the delta x was 2.5, we're trying to find time. So time is going to be 2.5 divided by 5.33. In order to solve for this, what you do here, you multiply both sides by t. So you get 5.33t, and that's going to be equal to 2.5. And then to get t by itself, you need to divide both sides by 5.33. That's just so that you can see how it works, because a lot of people get confused. So then 2.5 divided by 5.33 is going to be 0.469 seconds. So it's going to be in the air for just about half a second, which means that the speed at which it left, the 5.33, if it were to fall for more than a second, it would be a distance of over 5.33, based on that information. So this time is the time in the x direction, and it's also the time in the y direction, because these two things are the same, because the object is in the air, moving forward and moving down for the same amount of time.